欢迎莅临国立中央大学107学年度上学期地科院暨管院周会、唐奖大师第3届论坛与永续发展大师对谈。那现在我们的贵宾已经莅临现场，请大家给予热烈的掌声。Ladies and gentlemen, let's welcome the laureate of 2018 Town Prize in Sustainable Development, Dr. James Hansen. All of our distinguished guests, welcome. Good morning, our distinguished guests. Thank you all for joining us today here at the forum of 2018 Town Prize in Sustainable Development. We would like to invite the President of National Central University, Dr. Zhou Jingyang, to give us the opening remarks. Let's applaud to President Zhou.
Our honorable speaker, Dr. Hansen, distinguished guests, ladies and gentlemen, good morning.
Good morning.
Welcome to attend 2018 Town Prize Master Forum, a conversation with the Master of Sustainable Development, Dr. James E. Hansen. It is indeed our honor to hold this forum with the Town Prize Foundation. Dr. James E. Hansen, one of the winners of this year's Town Prize on Sustainable Development, is a professor directing the program on climate science, awareness and solutions of the Earth Institute at Columbia University. As a former director of NASA's Goddard Institute for Space Studies, GISS, Dr. Hansen has pioneered in fields such as global warming and climate change. In the 70s, Dr. Hansen co-created the GISS model, one of the earliest two general circulation models in the US, and the first to conduct research on and make quantitative explanation on how global temperatures are affected by changes in the interaction of water vapor, clouds, and the heat reflected by surfaces. Dr. Hansen is the first to compare temperature record globally and find a greenhouse warming signal above the natural variability. He has pointed out that the impact of greenhouse gases on the climate system not only has to do with the existing emissions, but also with the profound problem of accumulated emissions. Dr. Hansen not only supplies quantitative data on the threats of global warming, but also advocates meaningful actions and solutions. In 1988, as the head of GISS, Dr. Hansen announced before televised US Congress that global warming is here, on the grounds of the observed rising temperatures that exceeded natural variability. His testimony before Congress was the turning point for the world to know more on the subject of global climate change. His study-led scientific discussion was a critical foundation for future international climate protocols, such as the Montreal Protocol, Paris Agreement, as well as 2030 Agenda for Sustainable Development. In 1962, when National Central University was reestablished in Taiwan, our first academic institute was the Institute of Geophysics, which was grown into College of Earth Science eventually. This year is the 20th anniversary of the College of Earth Science. After 5 decades of effort, global warming, climate change, and sustainable development have become the anchors of the development of the college. Sustainable environments and energy policy are also two important research areas of the College of Management. That is why the College of Earth Science and the College of Management co-host this event today. After Dr. Hansen's speech, which is entitled Global Energy, Climate and Health, Making Your World, experts including Professor Liang Qiyan, Professor Lin Lifu, and Professor Yang Shuzhi will discuss the topic with Dr. Hansen on stage. As you know, Professor Liang used to serve as the Minister without Portfolio in charge of national energy policy and the effort on carbon dioxide reduction effort in the previous government. So he will moderate the discussion on stage. At last, academician Liu Zhaohan, our NCU's ex-president, will make the closing remark. At last, I'd like to thank you for your participation again, and let's welcome Dr. Hansen.
Thank you, President Zhou. Ladies and gentlemen, please applaud to the speech by the laureate of 2018 Compliance in Sustainable Development, Dr. James Hansen. Let's welcome Dr. Hansen's speech. Global energy, climate and health, making your world.
Thank you. Well, I'm glad to see so many young people. This really is all about you and your future and what we older people might be able to do to help you on the path that you're going to be on. So let's talk about global energy consumption, and the effect that it has on climate and human health, and especially about how young people can turn the problems that energy causes into opportunities. You know, fossil fuels are remarkable. They powered the Industrial Revolution. Yeah, this train, Omaha to North Platte, that's near where I grew up in western Iowa. Some scholars say that fossil fuels were the real basis for eliminating slavery, although perhaps we are all become slaves in another way. But living standards were raised by fossil fuels. People love and use the power that fossil fuels bring. 1 liter of petrol contains the work equivalent of 100 hours of labor by a healthy adult. So they're remarkable. Now, what do I know that would cause me, a soft-spoken Midwestern scientist, to get arrested protesting in front of the White House? Well, I was lucky to grow up at a time when it was not difficult for the son of a tenant farmer to make his way to the state university. And I was especially lucky to study under Professor Van Allen, who built instruments for the first United States satellite. Professor Van Allen told me about observations of Venus Venus was emitting intense microwave radiation. So the question was, did Venus have an ionosphere, or was Venus extremely hot? The answer, which was confirmed by the Soviet Venera spacecraft, was that Venus was very hot, 900 degrees Fahrenheit, and it was kept hot by a thick carbon dioxide atmosphere. So Mars, Earth, and Venus are a nice set. They confirm the greenhouse effect. The greenhouse effect is the excess temperature relative to what is expected given the amount of sunlight that each planet absorbs. As the greenhouse gas amount increases, this excess warming increases, and Earth is not too cold or too hot. It's just right for life. Then I was fortunate to join NASA, and I successfully proposed an experiment to fly to Venus. Our instrument was a little 1.5-inch telescope which took this image of the veil of Venus. This veil turned out to be a smog of sulfuric acid. Not a very romantic planet. But while our instrument was being built, I became involved in calculations of the greenhouse effect here on Earth. And because I realized that this is a more interesting planet because it's changing before our eyes. And there are people living on this planet, so it's important. So I resigned as the principal investigator on the Venus experiment. And I worked on using observations at weather stations to develop a history of the Earth's temperature. And with a team of colleagues to develop a mathematical model of Earth's climate. After 5 years of work, in 1981, we published an article in Science magazine concluding that the Earth had warmed 0.4 degrees Celsius in the prior 100 years, that the observed warming matched the calculated warming in our climate model due to increasing CO2, that Earth would warm more in the 1980s, and that warming would exceed natural variability before the end of the century. We also said that the 21st century would see shifting climate zones, creation of drought-prone regions in North America and Asia, erosion of ice sheets, rising sea levels, and opening of the fabled Northwest Passage. That paper was reported on the front page of the New York Times and led to me testifying to Congress in the 1980s. Testimony in which I emphasized that global warming increases both extremes of the hydrologic cycle, heat waves and droughts on one hand, directly from the warming, but also because a warmer atmosphere holds more water vapor with its latent energy, rainfall can occur in more extreme events, and there are stronger storms and greater flooding. Well, the Bush administration did not like my testimony, and the Office of Management and Budget inserted some changes in my testimony that made the effects of climate change seem more innocuous. After I complained, the publicity about these alterations, the hoopla, became very time-consuming and distracted me from doing science. So I decided to go back to just doing science. and leave the communications to scientists who were good at media communication, and some of them even enjoy it. However, by 15 years later, the evidence for global warming was much stronger. Most of the things mentioned in our 1981 paper were established facts. And I was privileged to speak twice to President Bush's Energy Task Force, which was headed by Vice President Cheney and included 6 cabinet members. But the U.S. energy policy continued to focus on finding more fossil fuels. At the same time, my view of the safe level of atmospheric CO2 began to diverge sharply from that of the prominent climate science communicators. So, and by then we had 2 grandchildren. And I decided that I did not want them in the future to say, Opa understood what was happening, but he didn't make it clear. So I decided to make a public statement criticizing the administration's lack of an appropriate energy policy. And after I encountered resistance to giving the talk in Washington, Professor Van Allen kindly arranged for a lecture at the University of Iowa in October of 2004. 14 months later, I gave a similar talk at the American Geophysical Union meeting in San Francisco. That talk led to several calls from the White House to NASA headquarters. And I was told that I could give no more talks or speak with the media without explicit prior approval from NASA headquarters. After I let this happen for a few weeks, and then I told the New York Times about it, and that forced NASA to end the censorship because of the publicity. But there were consequences. I had been using the first line of the NASA mission statement to understand and protect the home planet to justify my talks. But soon, this line of the mission statement was deleted, never to appear again. In the next few years, I was drawn more and more into communicating the urgency to change energy policies while still researching the physics of climate change. So let me describe 2 of the most important pieces of that physics. Adding CO2 to the air is like throwing another blanket on the bed. It reduces Earth's heat radiation to space. So there's an energy imbalance. There's more energy coming in than going out. The energy imbalance will exist until the Earth warms up enough to again radiate to space as much energy as it absorbs from the sun. As long as more energy is coming in than going out, then more warming is in the pipeline, and it will occur without any additional increases in greenhouse gases. Well, we can now measure that energy imbalance very accurately by measuring the heat content of the Earth's heat reservoirs and how that is changing. The biggest reservoir, the ocean, was the least well measured until more than 3,000 Argo floats were distributed around the world's ocean. These floats reveal that the upper ocean is gaining heat at a substantial rate and the deep ocean at a smaller rate. Energy is also going into melting of ice all around the planet, and the continents to depths of tens of meters are getting warmer. The total energy imbalance is now about 3/4 of a watt per meter squared. That's about 20 times greater than the rate of energy use by all of humanity. And it's equivalent to exploding 500,000 Hiroshima atomic bombs per day, 365 days a year. That's how much extra energy is coming in. And this imbalance means that there's more warming in the pipeline without any additional CO2. It also means if we want to stabilize today's climate, we must reduce CO2 from its present 410 parts per million, ppm, to about 350 ppm at maximum. That's the change needed to restore energy balance. Now, climate change deniers argue that the sun is the main cause of climate change, but the measured energy imbalance occurred during the deepest solar minimum in the record, when solar energy reaching Earth was least. Yet more energy was coming in than going out. So the effect of the sun's variability is overwhelmed by the increasing greenhouse gas due to fossil fuel burning. The other crucial information is from the Earth's history, which contains remarkable information on climate change. Global temperature, atmospheric CO2, and sea level over 800,000 years can be derived from ocean cores and Antarctic ice cores, from ocean sediments, and from the snowflakes that pile up year after year and form the 3-kilometer thick Antarctic ice sheet. And sea level is, of course, a measure of the ice sheet size. As the ice sheets melt, sea level rises, and you can see the strong correlation of these quantities. The climate change on these long time scales is instigated by oscillations of the Earth's orbit and the tilt of the Earth's spin axis. These orbital forcings are very weak and very slow. They occur on timescales from 20,000 to 100,000 years. The large magnitude of the climate change on these timescales is due almost entirely to two powerful amplifying feedbacks: ice sheets and CO2. As the Earth warms, ice melts and exposes darker ground that absorbs more sunlight. And as the ocean warms, it releases CO2, just like a Pepsi. CO2 changes more slowly than ice sheets, so it's the control knob on global temperature. As you can see from this remarkable comparison of atmospheric CO2 and Antarctic temperature. The same amplifying feedbacks must occur today. The physics does not change. As Earth warms, ice sheets will melt. CO2 and its companions, methane and nitrous oxide, will be released by the warming ocean, melting tundra, and wetlands. So let's tack modern data onto the paleo record. On the right of this chart, CO2 is shooting off scale. Temperature is also rising, but it has not caught up with the CO2. That takes time. Why? Because first, the ocean has great thermal inertia. It takes 100 years for the ocean surface to reach 2/3 of its equilibrium response in response to the increasing CO2. And second, there are slow feedbacks. Ice sheets do not melt overnight. The paleoclimate record shows that sea level lags the temperature change by a few centuries. So does that mean that our coastal cities are safe for several centuries? No, unfortunately, because human-caused change in greenhouse gases is much faster than any change in Earth's history. In our paper, Ice Melt, Sea Level Rise in Superstorms, we estimate that multi-meter sea level rise can occur in 50 to 150 years if CO2 continues to increase rapidly. And sea level rise does not need to reach several meters before the economic impacts become intolerable and the world may become ungovernable because cities become dysfunctional long before they are totally underwater. And more than half of the large cities in the world are on coastlines. Florida, the Netherlands, Bangladesh would be underwater, also a good part of China. Now, there's a second irreversible impact of rapid, large climate change, and that would be on other species. We're causing stress on other species in many ways as we take over the planet. We could commit to extinction 1/4 to 1/2 of the species on the planet by the end of the century if we stay on rapidly increasing greenhouse gases because of the combination of shifting climate zones with these other stresses. And that's an estimate of the Intergovernmental Panel on Climate Change. Coral reefs, for example, are the rainforest of the ocean. They harbor more than 1 million species. And they are threatened by many stresses, including ocean warming, which causes coral bleaching, and ocean acidification, which in the extreme can dissolve carbonate exoskeletons. We're losing more than 1% of the coral each year. If rapid emissions continue, especially with rapid sea level rise, we will lose most of the coral. Now, older people should actually notice that climate is changing, especially in the summer. Year-to-year variability of seasonal temperature in the 20th century formed a nice bell curve about the average. But now that bell curve has shifted. What was an unusually extreme hot season last century is now much more likely to occur. This change depends on location. In middle latitudes like the US and Europe, the shift is a bit more than 1 standard deviation in the summer, but it's smaller in the winter. In the subtropics, such as the Mediterranean and the Middle East and Southwest US, every summer is now hotter than the average climate 50 years ago. And that's almost true now in Southeast Asia. You should notice that the summers are hotter. This increased heat causes dry regions to have more drought and wildfires and a longer fire season. Because warm air holds more water vapor, so wet regions and rainy seasons can have more extreme rain and floods. Low latitudes are becoming less livable outdoors in the warm season, and more than half of the jobs are outdoors in agriculture or constructions. Higher temperatures also lead to a measurable increase in violence. These things are beginning to happen. Dry regions are having more extreme events. Here are fires in Greece this year, and these are more images of the effects of the fires in Greece. Fires, of course, have always occurred, but despite massive efforts to extinguish the fires in the United States, the area burned is increasing. 100-year floods are now occurring more than once a century. Unprecedented rainfall amounts in Japan this year. A warmer ocean surface and more water vapor in a warmer atmosphere provide more fuel for stronger tropical storms, tornadoes, and thunderstorms. This super typhoon had the strongest sustained winds over land that were ever recorded, reaching 195 miles per hour, which is well over 300 kilometers per hour. Yet the urgency of the climate crisis is not recognized by most of the public because of the ocean's thermal inertia. Much of the warming is still in the pipeline. And that warming will drive slow feedback, such as melting of permafrost and ice sheets. So, if the world does not reduce fossil fuel emissions, it will be an injustice to young people because we will hand you a situation that's out of your control. It also would be an injustice of the industrial North, which is burning the allowable carbon budget for the entire world. And of course, it's an injustice of humans to all the other species. So now you know why I got arrested. But after I was arrested 5 times, I realized, hey, this is not working. I was drawing attention to the injustice of climate change does not alter government policies. Energy use continues to grow. People want to raise living standards. People want to travel, and they will. They need air conditioning. The world needs energy. Governments give large subsidies to renewable energies and pretend this change will cause fossil fuel use to decline. Courage to use, well, you can see how much renewable energies are contributing, and they're not stopping the increase in fossil fuel emissions. The courage to use the true scientific method is lacking. So governments continue to seek more fossil fuels, and there's plenty to find. We have burned only the purple portion of these fossil fuels so far. The science is crystal clear. We must leave most of the remaining carbon in the ground. And we must extract some CO2 from the air, which is possible via improved agricultural and forestry practices. However, we had better leave young people a feasible task and some tools to address it. Young people must take up the fight and they must demand their rights. But to succeed, they must understand the matter and use the scientific method. We old scientists failed to change the world's course. I hope to explain to young people what I learned in the book that I'm writing, Sophie's Planet. And thanks to the Tang Prize, I expect to finish that book over this winter. Now, the core of the scientific method is simple in principle. You must use all the data, be very skeptical of your interpretation, and honestly reassess from scratch when new data become available. And your preference, your ideology, must not affect your assessment. So, in fact, it is difficult. Let's now consider human health as another huge issue associated with energy. China did an inadvertent experiment by providing free coal for winter heating to people in North China for several decades. This reduced the life expectancy by 5.5 years. Globally, outdoor air pollution, mainly from fossil fuel burning, is killing more than 3.5 million people per year. That's 10,000 people per day. The aerosols that people breathe in are so tiny that they enter the bloodstream, causing cardiac problems as well as respiratory problems. Indoor air pollution from burning of coal, wood, and other biofuels kills an additional 3.7 million people per year. And because these fuels are used for cooking, women and children are especially affected. And of course, many of the deaths from air pollution are prolonged and painful to the victim and to the family. So the crucial requirement to solve both health and climate problems is abundant, clean, carbon-free energy. However, fossil fuels will not be replaced by an alternative unless the entire energy system is economic relative to coal and gas, including the costs of additional transmission lines and energy storage if that is necessary. India will soon pass China in population, and India will pass the US in carbon emissions, becoming second to China. Renewable energy, the green area, provides only a tiny portion of the energy. It cannot stop growth of fossil fuels, let alone cause their phase out. Energy history of the United States is educational. Wood was the first energy source, but coal, with greater energy density, powered the Industrial Revolution until the more convenient liquid and gas fossil fuels were discovered. Because fossil fuels are a finite resource and a big pollution problem, it was hoped that peaceful use of nuclear power would be a major long-term energy source. There's enough nuclear fuel, enough uranium in the ocean to last forever, for billions of years. So it would be possible to stop mining of nuclear fuel. Nuclear power could practically eliminate CO2 emissions as well as air and water pollution. However, development of nuclear power practically stopped in the 1970s. What happened? The root problem for nuclear power is concern about health effects of atomic radiation. Until 1956, it was assumed that there was a threshold for harm, consistent with the idea that radiation is probably not dangerous if it's less than the amount that we get naturally from cosmic rays and radioactive elements in the soil. Some scientists even argue for radiation hormesis, that the idea that low levels of radiation are beneficial. However, in 1956, the National Academy of Sciences Baer Committee, the biological effects of atomic radiation, declared that the tiniest amounts of radiation are harmful. And Linus Pauling used the idea that even the tiniest radiation is harmful to help achieve a ban on atmospheric testing of nuclear weapons by the US and USSR. This, incidentally, however, had an effect on public perception of nuclear power. Public attitudes were also affected by the 1979 disaster thriller, The China Syndrome, about the danger of a nuclear meltdown. This film almost coincided with an actual accident and partial core meltdown at the 3 Mile Island power plant in Pennsylvania. So enthusiasm for nuclear power in the US dissipated, even though it was determined later that the radiation released did not harm Pennsylvania residents. This is from a concert.
I want the energy that we have now. We have to have either oil or coal or whatever, but certainly not nuclear. Even wood if need be. I have a coal stove at home if you want to know. Flash! Yes. Put it on. I don't use it now, but if I have to, I will. And I live 1 block from the mayor, and I have a coal stove. Put that in your house and smoke it.
Of our movement. Just give me the warm power of the sun. Give me the steady flow of the waterfall. Give me the spirit of living things as they return to clay. Just give me the restless power of the wind. Give me the comforting glow
So did you hear the line in the song, "Give me the warm glow of a wood fire"? And remember that 10,000 people per day are dying from indoor air pollution. Proponents of nuclear power continue to argue that the Baer Committee was wrong, that LNT is not correct and was ideologically driven. I doubt that this battle will be fruitful. Small radiation effects are difficult to prove and depend on the circumstances. In such case, health professionals are likely to prefer the strictest criterion, which is LNT. However, I think young people have a good basis to be unhappy about us old people not being very scientific and for not being objective. We owe it to young people to provide an honest comparison of the health and environmental effects of nuclear power, the health and environmental effects of renewable energies, and the health and environmental effects of fossil fuels. We have the scientific ability to make such comparisons. We just haven't done a good job of doing that. And young people have more reason to question the wisdom of us old people. President Clinton, 25 years ago, terminated research and development on nuclear power just when the Department of Energy was ready to build an advanced generation nuclear reactor, which had major improvements over the old technology that we're using now, which is 50 years old. Nuclear power in the United States actually has an outstanding safety record, but the next generation can be even much safer and produce less nuclear waste. So I'm not advocating any specific technology, but the potential of a number of technologies really should be developed, and so that we have choices in future energy. That means the Nuclear Regulatory Commission and Department of Energy need to facilitate the progress rather than stopping all the research and development. So let me give the last word on this topic to my oldest grandson. Here at age 7, reading an Indiana Jones book about an urgent problem. A few years later, he was 10 years old, Connor correctly identified two basic conclusions about the energy-climate matter. First, if grown-ups keep doing what they're doing, and kids cannot figure out a time machine that actually works, then kids are screwed. And second, some grown-ups are scared of nuclear power, but what about fossil fuels? We know that fossil fuel are not safe. They're very dangerous. Now, let's consider the solution to the health and climate problems. The essential requirement is a rising carbon fee to make the price of fossil fuels honest by including their human health and climate change costs. It's easy to implement an across-the-board carbon fee, collecting it at the first sale at domestic mines and ports of entry. If 100% of that money is distributed equally to all residents, then we have a simple, transparent, market-based approach that spurs innovation. With the present distribution of energy use, 70% of the public will make money. But if they want to stay on the positive side of the ledger, they need to pay attention to the price of things on the shelf, because those things that employ fossil fuels in their construction will become more expensive. So most rich people have a large carbon footprint, so they would lose money. They have bigger houses, they fly around the world, but they can afford the additional cost. Such an approach spurs the economy, creates jobs, increases the GNP, and increases government revenue. It's the one effective international approach. If the United States and China would adopt a carbon fee, they would also impose border duties on products from countries that do not have an equivalent carbon fee. And that would be an incentive for other countries to adopt a carbon fee so they can collect the money themselves rather than have China and the US collect it at the border. So the crucial requirement is a price on carbon to make the price of fossil fuels honest. And some regulations will still be required, and governments must support research and development because it's essential to have 100% carbon-free electricity. And it's important to recognize national responsibilities for climate change, which is proportional to the cumulative emissions. The United States, the United Kingdom, and Germany are much more responsible for climate change than the developing countries. In other words, the West burned much more than its fair share of the global carbon budget. And that's an added reason for the West to assist in reducing emissions in developing countries, in addition to the fact that we're all in the same boat together. So how can we reduce emissions from the big future emitters? If I want to be popular, if I want to find research support easily, I must say renewable energies can provide all of our energy. If I want to be a good scientist, I must look at the data. Does it make sense to place all of our eggs in one basket to make the assumption that renewable energies by themselves will rapidly replace fossil fuels? I think that young people should be angry. I don't think that old people have the right to gamble the future of young people on that assumption. I doubt that the climate problem will be solved by 190 nations sitting around a table. What is required, I believe, is the United States and China to agree on the need for a carbon fee. They could readily impose it on a near global basis. However, this will not happen in the absence of technological advances that allow practical economical movement to carbon-free electricity in countries such as China and India. For that to happen rapidly requires concerted, high-priority technology cooperation. You know, you hear the notion that, well, humanity can escape to Mars. That, of course, is nonsense. We either have to learn to work together and preserving our remarkable home planet, or else we sink to the abyss together. China and India are not the only big emitters. There's also the United States, which has withdrawn from the Paris Agreement and says that climate change is a hoax. Nevertheless, there's a basis for optimism. The United States is still a nation of laws, and 21 young people and I have filed a lawsuit against the federal government demanding a national plan to phase down emissions rapidly. I expect that we will win this case, even with a conservative Supreme Court, because our case is based on the most fundamental constitutional principles. Young people are being deprived of life, liberty, and property without due process of law. They are not receiving equal protection of the laws. It's analogous to the case of civil rights in the 20th century. But the courts cannot write laws, so it's important to also influence the legislative branch. Good progress is being made in the U.S. by a rapidly growing organization, Citizens Climate Lobby, which has carbon fee and dividend as its objective. The members use the democratic process. They visit Washington. They speak to Congress people. They also write op-eds and letters to the editor. I think that joining this organization is probably the single most important thing that a citizen can do to address climate change. There are CCL branches in about 30 countries, including India, but not in China or Taiwan. So that's something that you might think about. Thank you.
Thanks for the amazing talks given by Dr. Hansen. 那我们现在呢，马上将进行综合座谈。由于本活动的目的在于促进得奖人与社会大众以及青年学子的交流，因此我们现场将开放提问，请各位将您想问的问题写在入场时领取的提问单上，并交给走道的工作人员。我们将由主持人统一进行提问。Now, let's welcome Dr. 梁启源, Chair Professor, School of Management. Dr. 林立夫, Professor of Department of Mechanical Engineering. Dr. Yang Shuzhi, Associate Professor, Department of Atmospheric Science. Please have a seat. Professor Liang will be leading the panel discussion.
President Zhou, distinguished guest, Professor Hansen, thank you again for your inspiring and excellent speech. And climate change and its solution is an interdisciplinary science. So, in this panel session, we invite 3 panelists that is from different fields, experts in different fields. One is from climate scientist viewpoint. Another one that is Professor Professor Yang, and another one is from energy technology point of view, that is Professor Lin. And myself is an energy economist. So 3 of these panelists, we participate in our discussion with Professor Hansen. So I suggest that the first speaker will be Professor Yang from a climate scientist point of view. Would you like to comment? Yeah. So shall we welcome Professor Yang's presentation?
Okay, good morning to all our distinguished speaker, guests, and everyone here. And I'm Shuzhi Yang, and today we have this almost like a prestigious opportunity to have Dr. Hansen with us, sharing his journey and vision about understanding and finding solutions for global warming. And as a metallurgist, I would also like to take this opportunity to bring up discussions about what condition are we facing in Taiwan under global warming, and are we close or beyond the point of no return? Okay, so before I start, please allow me to pay my greatest respect to Dr. Hansen, who is a climate science the pioneer and the champion for truth. And I'm not going to go through all of this, but I would like to point out that actually around the early 2000s, when we start to talk about global warming and the concept of that the great impact from anthropogenic, the greenhouse the gases on the extreme weather has been is well delivered until now. But actually before 30 years ago, in 1981, actually Dr. Hansen already pointed out this fact in his 1981 science paper. And after that, since then, he not only devote his research on climate change and also really take the actions. So for example, in 2006, the letter, The Threats to the Planet, he actually clearly said that he urged people and the government that we should take action and we should to make, for example, energy policy to slow down the CO2 emission. And in 2009, he also fought for young generation and future generation in his book, Storm of My Grandchildren. And I have to say, unfortunately, a lot of Dr. Jim Hansen's prediction become truth nowadays. And 2 years ago, Dr. Hansen led a group of 19 researchers and published this paper, Ice Melt, Sea Level Rise, and the Superstorms. And from evidence from the paleoclimate data, climate modeling, and the modern observation, and point out that, and this number, of course, you are all very familiar with, 2 degrees Celsius global warming could be dangerous. Okay, so that's sort of, so currently that brings up this like a big question. So are we close or beyond past this point of no return? So in the following, I would like to show you some scientific evidence from, for example, from Professor Will Stevens, a very recent work. And he pointed out that the global warming actually will be accelerated if we consider not only the human emission, but also with the biosphere degradation. And he stated that we are pushing the planet toward an irreversible hothouse Earth that's already past the point of no return. And we may be much closer to the point of no return than most people realize. And so I would like to also take this opportunity to let you know that the situation in Taiwan, and actually we are facing an even more rigorous condition under global warming. So here I'm particularly list out important findings from NCDR TCCIP, the report. And that's the main 5 findings from the report. And the first thing is that in the long-term future that we will have evident warming, in particularly northern Taiwan. And so you can see, okay, so this is Taipei, right? So there's a very evident warming in northern Taiwan. And I hope you remember that this past May, we have this record-breaking high temperature and also number of days of high temperature that's in 30 years. And this suggests that summer starts earlier, leading to longer summer and shorter winter. And all this extreme high temperature bring the heat wave and danger people's health by getting more possibility of getting heat stroke. And of course, you all remember this extreme heavy rainfall event from last month to early this month. And this is the total precipitation rainfall in Tainan City. And you can see that we have more than 1,000 millimeters rainfall within 1 day. And so not just the precipitation intensity surprised us, but left us tough condition of floods and mud flows. And so I would like to emphasize that all these extreme events are happening, occurring in Taiwan. And the last one you probably also noticed from news saying that although the number of the typhoons is decreasing, but the intensity is potentially increasing. So when typhoon comes to Taiwan, we will be facing an even more threatening condition than before. So for young people, so don't be too frustrated. So I would like to sort of bring up discussion. So I say that we are facing this a rigorous condition, but how are we able to survive in the future? So the next I would also like to sort of raising some hope and tell young people that actually through climate science study, this will help us to understand what we are facing in the future. So I'm listing a few the very recent work published on top journals. And the first thing is I would like to use this example that there is a very important quantity called equilibrium climate sensitivity, ECS. This number is adopted by IPCC, used to measure the threshold that how can we, the number that we can stabilize global warming relative to pre-industrial climate. And this number actually, the likely range is actually quite large, from 1.5 to 4.5. And this range remained for like more than 15 years. And recent work in Nature by Professor Peter Cox, he mentioned that he used a different methodology and focused on historical warming instead of warming trend. And he said they may be able to rule out some of the most dire scenario and tighten the likely range to 2.2 to 3.4. And this number is saying, yes, climate warming, global warming, climate change is real and bad. It's happening. But the worst scenario of 4.5 degree may not, has a very low probability to happen. And also regarding from point of view of observation, we also have a lot of discussion that we are losing the carbon reservoir, and recent work by Professor Jeff Trenton suggests that actually they analyzed the peatland sampled at different latitude. Peatland is 泥炭地. Okay, and they found that actually peatland down below the earth is more stable than we intuitively thought and may help to avert the worst case scenario and temper the dreaded carbon bump. But another message he still tried to deliver is actually, this doesn't say that global warming is not happening. This actually compared to, so all the nature processes paled in comparison to the rate at which actually people releasing CO2 into the atmosphere. So, but it's just that the worst scenario can be that maybe slow down. And so there are potential, and of course there are the potential solution also pointed out by Dr. Hansen, and I think the very first priority is that we should control the emission of anthropogenic greenhouse gases and pollutants and even super pollutants. And a very recent interesting idea by Professor Eugenia Kaunade, she and her group pointed out that by implementing large-scale windmills and solar panels may mitigate the Sahara from expanding. So what I want to say here is the worst scenario may be avoided, or I should say more scientifically redefined. But global warming is real and bad. It's all generations' responsibility. I know Dr. Hansen said young generation, he fought for young generation, but I think it's all generations' responsibility to face this problem, understand the problem, and make our environment, the earth, sustainable by all means. And my very last words is we should not wait until all science is solved before taking action. So should I start ask question or?
Yes.
So can I?
Yeah, you can raise the question.
Okay, so I'm very grateful to have the opportunity to ask two questions. So first is in terms of science that we know that IPCC concluded that there are four main uncertainties. And so what is the largest uncertainty in current climate modeling, or I should say Earth system modeling for projecting future change? And because my specialty is in data simulation, so I would like to ask what observation or what type of instrument would be most helpful to reduce uncertainty or sensitivity estimation? And that's my first question. And the second question is, it's time to take action, and probably Dr. Hansen partially answered this question during his talk, but I still want to ask that do we underestimate the potential of renewable energy? Because recently I learned that actually in Hawaii, most of the energy is produced by solar energy, and they may overproduce the solar energy. So that may be some kind of hint that if we can handle the renewable energy or making a better policy, we may be able to really push the renewable energy to a level that we need. And is that realistic if we can convert the same investment in nuclear energy to advance the technology of the new renewable energy to achieve the same goal for reducing CO2 amount? Thank you very much.
Thank you, Professor Yang.
I think we just
Professor Hansen
decided
would
that
like to respond quickly.
that I would make a very quick answer to those questions, but we don't want to spend a lot of time on that now because we want to be able to interact with you. But I can make a quick answer to this first question about what are the big uncertainties and what are the observations, because I didn't talk about it, but in addition to greenhouse gases, humans are affecting climate by putting particles in the atmosphere. I mean, you can certainly see them in Taipei. There's very much pollution. The stuff that you see is not greenhouse gases, it's aerosols, it's small particles. And those affect the sunlight, the amount of sunlight that the planet absorbs. And yet, we're very ignorant. We measure greenhouse gases very precisely. We're not measuring aerosols because they're harder. We actually know how to do it. And because my group and I proposed an instrument which would do a spectacular job of measuring aerosols, is a small, same instrument we used on Venus to determine the sulfuric acid on Venus. And that's a very high precision polarimeter. But NASA didn't like me, and they launched it into the Antarctic Ocean, and they never built another one. You need to cooperate with China or somebody to get such an instrument, because we have to know aerosols. If we stop burning fossil fuels, we're going to reduce the amount of aerosols in the atmosphere. An important climate problem, important research problem. That's the big uncertainty in this problem. And with regard to the second question about renewable energy and nuclear power, yeah, I just say we have to let these, the difficulty with renewable energy, of course, is that it's intermittent. And so you either have to have energy storage, or you can try to connect different areas with transmission lines, and when the wind is not blowing here, maybe it's blowing over there. But it turns out you need a lot of transmission lines, and it turns out the utility engineers say that's going to be very expensive. So we don't know how much of our energy we can get from renewables in a practical way. Of course, in principle, you could get all your energy if you have storage. And Elon Musk is working on batteries that everybody can include in their basement, a huge battery. But that battery only carries over the diurnal cycle. It doesn't carry the energy from one season to another. So it's a very hard problem to solve with batteries. But let these things compete. If you put a price on carbon that's rising, then let the alternatives compete. If I were a young person, what would I do? I would not be working on planets the way I did when I was a young person. I'd be working on energy, technology, and in particular, because of what I know as a physicist, and I know what the potential is. One ping pong ball sized nuclear fuel provides all the energy that a person uses in 100 years living at the lifestyle of an American, which is wasteful, 200 years of a European. So there's a potential there, and I think that's what I would work on, trying to make a safe nuclear reactor, but that's my choice. But anyway.
Thank you, Professor Hansen. So next speaker will be Professor Lin. He is an energy technology expert. So from the point of view of energy technology.
So ladies and gentlemen, good morning. I am honored and a pleasure to join this panel discussion. I would like to share with you the importance of the CCS in the net zero carbon energy infrastructure. Because in order to keep the Earth from the threat of the climate change, we should keep the Earth, the global zero carbon emission by the end of this century for the 2D scenario based on the Paris Climate Accord. And we expect the net zero carbon energy infrastructure should become a norm for the future low carbon economy. The CCS is the abbreviation of the CO2 capture and storage. The function of the CCS is to capture the CO2, which will be emitted into atmosphere and pumped into the appropriate geostructure. The next slide. So in Taiwan, we are lucky we have two kinds of the appropriate geostructure for storing the CO2. The total capacity is around 20 gigaton. In 2017, annual emission of CO2 in Taiwan is around 0.25 gigaton. So the ratio between the capacity and the annual emission in 2017 is around 80. So the next. So this slide, we schematically presented the net zero carbon energy infrastructure. It composes three parts, namely the power grid, gas network, and the CO2 infrastructure. The power sector will be decarbonized by improving energy efficiency, deploying the renewable energy, as well as nuclear energy, and also implementing the smart grid, as well as the CO2 capture and storage. The gas network, as well as the energy storage system, will expand dramatically with the boom of the renewable energy due to the flexible backup power for the coming power grid. The CO2 produced by the gross emitter, which will be captured and pumped into the CO2 infrastructure, where the received CO2 will be sent to the user with priority, and the rest of CO2 will be stored underground and reused in the future. This kind of approach is believed to be the most cost-effective way to reduce the carbon footprint for the cluster of the large CO2 emitters. So if the advanced technology could demonstrate their viability, so the excessive renewable electricity or a photoelectrochemical process could be used to convert the water and capture CO2 into the hydrogen as well as the C1 chemical, which will be distributed to the user through the gas network. So in total, the objective of the zero carbon energy infrastructure is to smoothly transfer the fossil fuel industry or era into the low carbon economy. So the next slide. So based on the emission gap report 2017 from the UN Environment, it's clearly demonstrated the gap of emission target between the Paris Climate Accord and all of the national determined contribution. The gap will be reached in the range 11 to 19 gigaton CO2 equivalent in 2030. In other words, we are closing to the overshooting the carbon budget, and we are closing to the unsustainable tipping point. So the next slide. So if the carbon budget was overshot, the only effective countermeasure to rescue the Earth is the negative emission, which could timely offset the excessive CO2 in the atmosphere. Today, the most mature and available negative emission technology is the biomass combustion plus CCS. So, next slide. So based on the report tracking clean energy progress in 2017, published by International Energy Agency, the major contributor of negative emission technology, namely biofuel and the CCS, is belong to the category, the out of the track. So, in order to facilitate the resilience of our next generation against the threat of the climate change, our generation, we should take prompt action to fix it. Okay, the next, okay. So, in addition to reduce the carbon footprint, the CCS could be also beneficial to improving the impact on human health and the ecosystem. This data shows the option of coal plus CCS is superior to the natural gas combustion without CCS. Okay, the next slide. So in Taiwan, the integration of the CCS with the coal gasification could also develop in the profitable business by producing the syngas to substitute the import LNG. The data in this slide show the clear price spread between the import LNG and the syngas produced by the coal with the CCS. Just give an example. If we outlook 2020 to 2040, the import LNG will be in the range $11 to $14 per million BTU. If we produce the syngas with $2 per million BTU, the price could be in the range $60.5 to $8 per million BTU. So the price premium is at least $5 per million BTU. Okay. So in Taiwan, if we examine the emission gap between the energy transmission roadmap of IEA and all of the action of Taiwan, you will see the gap will be enlarged with the time. Since in Taiwan we have natural resources to accommodate the CO2, and we also have the niche market to initiate the CCS business. So it is strongly recommended here the option of CCS should be urgently included in the portfolio of decarbonizing policy for Taiwan. So, okay, that's my presentation. And I will also take this opportunity to share with you one question or one comment asked from Professor Hansen. So Professor Hansen promoting the carbon fee and the dividend action. And for me, carbon fee is okay. The dividend approach, I have some concern. If the carbon fee and dividend were in success, it is no doubt the public support basis will be enlarged for combating the climate change. It is also for sure it will weaken the competition of the fossil fuel industry. But my concern is the current insufficient investment in the low carbon infrastructure is still in a dangerous situation. So my proposal is we should effectively use these correct resources and invest smartly in a cost-effective, low-carbon energy infrastructure. So, ask your comment.
Okay, thank you. Yeah, would you like to?
Okay, I think if I understood correctly, he's asking the question of, or suggesting that the money that's collected in a carbon fee, what I had suggested is all of that money should be given to the public, an equal amount to all legal residents, so that the person who does better than average in limiting their carbon footprint will make money. And in fact, with the present distribution of energy use, it's the rich people who will lose money, and 70% of the people would gain money. And in a democracy, I think that's necessary to give the money to the public in order that they will support the carbon fee, because they don't like taxes. They don't like to see the price of gasoline at the pump, of petrol at the pump to go up. Now, however, whenever I talk to a politician, they always know they want to use the money for this or that. And you would like to use the money for investments. Well, I agree that we need money invested in these new technologies, and it could include carbon storage. If you can, and the price for carbon storage, the amount of money that would be the same as the tax. You know, if you can store permanently some CO2, then you can sell that right to somebody who wants to pollute, who wants to put CO2 in the atmosphere. So you can easily accommodate your CCS in the total package of policies. You can easily accommodate it via the carbon tax or carbon fee. But I would think that the investment money should come basically, if you see this, if this carbon fee is rising and everybody knows it's going to keep going up, that will encourage entrepreneurs to invest. And that will be, I think, the main source of, I'd rather see the public economic system do the decisions rather than the government bureaucrats. If government bureaucrats decide on how money is going to be spent, it never turns out to be as effective as if you let the monetary incentives drive it. But I agree that some things have such a long lead time that government has a responsibility for supporting some R&D. And that's the problem. They've done very well in supporting renewables. There's been a virtually infinite subsidy of renewables, at least in the United States, via something called renewable portfolio standards, where utilities are told they must get X% of their electricity from renewable sources. And that is an enormous subsidy, because all the other ratepayers buying electricity have to pay for that. It would make more sense to say have a clean energy portfolio standard. If you want to require the utilities to have more and more clean energy, then allow everything to compete. So this was the way in which so-called environmentalists could kill nuclear, by having renewable portfolio standards, because nuclear was left out. And that was a mistake. So it's kind of an indirect answer to your question, but I would rather see most of the investment come from the private sources who will want to make money.
Okay, thank you. Now, I would like to have a short remark from a energy economist point of view. Dr. Hansen is a pioneer, scholar, spokesman, and a fighter for warning our world about global warming. He has found solid facts for its severe consequence and its relation with greenhouse gas emission and suggests solutions to cope with climate change. He liked to put on a hat. Do you see him? Like Indiana Jones, like his grandchildren. Indeed, his law of fighting with global warming is like the law of Indiana Jones in the movie of the Raider of the Lost Ark, 法柜骑兵, to fight with the evil empire. For reversing the trend of global warming, it is vital to change the energy policy. He suggests, first, to substitute fossil fuel with zero CO2 nuclear power and some, not 100% renewables. Second, to levy carbon tax on fossil fuels for reflecting honestly their human health costs and climate change costs. However, the government of Taiwan at present, actually, for this suggestion, I fully agree with him. In fact, this kind of policy is actually proposed and adopted by the former government, mind your government. However, the government of Taiwan today has chosen a path to reduce nuclear power from 16% of total electricity generation in 2014 to 0% in 2025. In the meantime, our government continues to subsidize fossil fuel. For instance, the electricity price is supposed to increase in October, but it's stabilized. I mean, it's freeze, not increase at all. The policy might result in the following drastic impact on Taiwan. This is an energy transformation policy. Renewable will increase from less than 5% 2017 to twice over that by 2020 and fourth over that by 2025. But we have a problem because we have a limitation of land. So, for instance, 73% of renewable to reach the target by 2025, we need 25,000 acres, 25,000 hectares land. But because of problem of about the electricity wire grid, and also difficult to handle, resolve the land acquisition problem. Only 1/5 of that is available. So it's really difficult to reach the target. And gas fire, from 1/3 of electricity generation to 50%, 1/2 electricity generation. But we had to finish Terminal 3 at first. But we have problem with that. So this is difficult. And coal-fired power plant will be reduced from 47% to 30%. But if this substitute for the nuclear energy cannot be cannot be fulfilled. We have a problem to retire or reduce the coal-fired power plant. So it's also a problem. So from 2014 to 2017, the share of the nuclear in total electricity generation has decreased from 16% to 8% last year. At the same time, Taiwan's reserve margin rate almost reduced at the same magnitude, close to 8%, which was much lower than a reasonable reserve margin rate at 15%. So the 71% reserve margin rate in 2017 was as low as that during 1990 to 1996. During 1990 to 1996, electricity outage totally 43 times, not 6 times, typo, 43 times. The risk of electricity outage did happen in October 15 last year. This is a comparison of a reserve margin rate. And actually, last year it was 9.8 because nuclear 2 reactor is included here. If it's extracted, it's deducted that only about 7.1%. That is close to 1990 and 1996. At the time, the reserve margin rate is lower than 7%, even lower to 4.2%. So in 1994, the electricity outage is beyond 15 times in a year. Okay? So now our situation similar to that period. So we did found that reserve margin rate less than 10%, that is accounts for about 2/3 of the days in 1 year. Compared to the past, it's increased drastically. And operation reserve rate less than 6% is 1/3. That is a power supply alert. Okay? And this year as well, this operating reserve margin rate is even higher than last year. And now, operating reserve rate, that's the actual reserve rate, it's about 29 times. That is because nuclear 2 is reoperated. Okay? Otherwise, we have even more severe problem than last year. But the reopening of reactor 1 and the reactor 2 of nuclear 2, indeed, totally is about 6%, can help to relieve the electricity shortage in recent years. However, Taiwan has still need to face the challenge of 21% loss, that is together with nuclear 4, in electricity supply during 2021 to 2025 due to zero nuclear policy. So particular threat is on northern Taiwan. It is estimated by 2020, North Taiwan's power shortage will be more than its reliable high voltage transmission line capacity. That roughly is below 3,000 megawatts. That means once an extra high voltage transmission tower collapses, large-scale power outage crisis will happen in North Taiwan. And electricity price increase. That is compared with 2016 last year, price by 2025 will increase by close to 50%. And the greenhouse gas emission and pollution will come together because, as I said, that to substitute nuclear with renewable and natural gas has some problem, okay, big problem. So it's difficult to substitute nuclear and in the same time to reduce the coal-fired power plant. So if that happens, substitute nuclear by coal-fired power plant, our CO2 emission will increase 18% instead of a decrease. Okay? So our energy security will be in danger. 99% of Taiwan's natural gas rely on import. The average of a stockpiling can last for 13 days only, in an average, 1 year average base, which is much lower than most of the neighboring countries, like 53 days for South Korea, 51 days for China, and 36 days for Japan. In summertime, the stockpiling can last only for 7 days. So if 2 or more typhoons beat it in 1 week, Taiwan might lose 1/3 of present power supply, because now a gas fire accounts for 1/3 of our electricity generation. But by 2025, it will be accounts for one half of the electricity supply. So that is not only energy security in danger, but national security also in danger. Only by typhoon, we defeat us. This is the comparison with China, Korea, and Japan stockpiling, Taiwan here. We know that Professor Hansen wrote a letter with other 18 distinguished scientists to President Tsai Ing-wen to urge her to change the policies on October 23rd last year. So my questions are as follows. What is President Tsai's answer? This is also a question raised by students. And second, are you satisfied with her answer? And number 3, do you have some suggestions? Because government don't listen to us. So for our citizens, this is our duty. Scientists, energy experts, intellectuals, students, media, and others to follow up. Thank you very much. Thank you. That has several questions from the floor. But because the time constraint, so maybe not all of that, maybe have time to answer. So the question from the floor is that, what kind of breakthrough must be made in science or technology to solve the global climate change problems? What kind of technology? Maybe too many questions at one time, so.
Oh, okay, he's asking me first to answer his question about your president. Well, the answer is, of course, that is given by your own chart, and that is, this plan. There's no indication of an understanding of what is required to reduce Taiwan's emissions and give Taiwan clean energy. It's not just, it should not be just your concern about your CO2 emissions and future climate, but also just the human health. I don't know if this was unusual, but boy, in the last week that we've been here, there's been some pretty bad air pollution. If you look at if Taiwan's pollution were average, if it were average for the world, then given the population of Taiwan, the number of people that would die per day is 30 to 40. And number of people who are affected because of air pollution, and the number of people who are affected by their health is affected is orders of magnitude, is much larger. But I would guess, so I mean, it's really worth looking at that. That's what I said when you need to make a comparison of the different energy sources. People are just not sufficiently concerned about the air pollution effects. The impact of the health effects on the individual is really pretty dramatic. It's almost like getting cancer from smoking or something. It affects not only a very unpleasant way to die, and it's also very unpleasant for your family members. So I just think that this human health aspect deserves a lot more attention than it gets. And I think that if you look at it carefully, you'll probably find that Taiwan's pollution is, at least Taipei City, is worse than global average. It looked to me like it's worse. So this, I think, getting most of your electricity from coal and gas is really a bad situation to be in. And the fact that the government is just making this half-baked effort to, in effect, supposedly replace coal with gas and replace nuclear with gas, that's such a minor effect. I don't think you should accept that as an answer. And I don't even believe, when they're talking about building a new coal plant, then they don't even believe that they're really going to be reducing coal from 43 to 30. And so let me use this opportunity to say one more thing about the potential for advanced generation nuclear power. You know, I think Taiwan has a remarkable potential to be a global leader and affect the whole path of the world. Because you have it appears to be a very difficult situation for nuclear. You're sitting on a fault line. You know, you have the likelihood of earthquakes and volcanoes and typhoons. But what is the potential of technology? I helped organize a workshop in China 2 years ago. Our principal thought was, gee, why not build the next generation of really safe nuclear reactor on a ship? Because a ship is not affected by earthquake or typhoons. The studies at MIT show they just ride it out, you know, and it's so easy. And so, given Taiwan is a very highly educated public compared to the world average. It's got people overqualified for their jobs. You have the potential to be world leaders in technology development and energy development. And this kind of a plan that ends up still using coal and gas for most of the electricity is crazy for Taiwan. Taiwan should have much higher aspirations and should be a world leader.
Thank you very much. Is that time? Okay. Time limited. I have so many questions. I'm so sorry that we don't have time. Another two? Okay, good. So my second question, I obey order. So, is there any possible way to reach the same effect of implementing carbon tax or carbon right without government action? That is
Yeah, so, you know, the problem that we face, I have found, this is the first visit to Taiwan, but I visited more than a dozen other countries. I thought the United States political system was really in bad shape because our democracy has been totally disrupted by the role of money. Our national political leaders are in a swamp where the special interests are controlling. All Congress people, senators, representatives, and even the executive branch take donations, huge donations from special interests. And so I've found it impossible to get either political party to really go along with the policies that are in the best interest of the public. But therefore, in the United States, the bottom line of this book that I'm writing, Sophie's Planet, is going to be, I think we need a third party which will take no money from special interests. And we've already proven that you don't need it. And who proved it? It was young people. In 2008, Hillary Clinton was supposed to win, was expected to win the Democratic nomination, but young people preferred Barack Obama. And they, without any money, except by $20 donations, no money from special interest, Barack Obama's campaign took off and surpassed Hillary Clinton's. And it was because young people were knocking on doors throughout Iowa primary, and they know how to use the social media. So they didn't need expensive television advertisements. Then, 2016, Bernie Sanders, everyone expected Hillary Clinton had locked up the Democratic nomination, but young people didn't like this. They were supporting Bernie Sanders, who was a socialist, who was someone you never think could win anything. He almost was able to overcome because young people. Bernie Sanders went to college campuses all around the country. Young people came out by the thousands. And so, young people have the potential political power. But what happened was, in the case of Barack Obama, they didn't know what to ask him. And so, because he said, we have a planet in peril, they just assumed he's going to take care of the climate problem. He could have had some policies, because initially he had control of the Senate and the House. But he had other priorities, and he wasted the economic crisis that he had. He could have put a price on carbon as and used that to spur the economy. But he didn't do that. He didn't understand the problem. So next time young people elect somebody, they've got to understand what they need, and they've got to demand it. And that may be true in other countries like Taiwan. You need to understand the situation.
Yeah, the last one is a privilege for the former president of Central University, President Liu. Will you raise a question? Okay, yes. So I think just a short one. What is your prospect on the nuclear in the future?
Well, I think that there's tremendous potential. There are a whole lot of startup companies that want to get started, but the problem is because of we didn't do the long-term R&D over the last few decades, which was kind of stopped. And the big problem is the United States is not cooperating with other countries. I mean, it's actually preventing countries from having access to technologies and prohibiting nuclear development, which is not only short-sighted from the standpoint of the future of the planet, but it's irresponsible in the sense that we have to recognize that we burned most of the carbon budget. The United States has put more than twice as much of the excess CO2 than any other country. China is next, but even though it has a huge population, the United States has put twice as much up there. So we have a responsibility and to help with the technologies. So I think we have to get future administrations in the U.S. to stop preventing the kind of things that some of the countries have wanted. And I know Taiwan was one, and there are some other countries, India, that wanted things, but the U.S. is blocking it, because the U.S. is still in a powerful position to hamstring technology development. We've got to get that to change. So I intend to try to make an issue of that, because the future of young people on the planet depends on it.
Thank you very much. I think everyone agree with me. It's a wonderful panel session. And could you join me? Thanks Professor Hansen, Professor Lin, Professor Yang for their excellent speech and discussion. Thank you.
Thanks for Dr. Hansen and all panelists.
Thank you.
Now we are going to invite the academician of Academia Sinica, also our former president, Dr. Liu Zhaohan, to give us a brief conclusion for today's forum. Let's welcome Dr. Liu.
Well, I think we have, I hope that everyone here is just like myself, really enjoyed Dr. Hansen's talk, and also the very spirited discussion in the forum. And in Dr. Hansen, I think we all see a prominent scientist, how a prominent scientist applied his knowledge, scientific knowledge, and devoted many, many years of his life to try to affect the policies of the government that really is important for humanity to solve our most urgent problems. With increasing degree of success, as we see it. And here in Taiwan, I think this is very timely and also very relevant to Taiwan, because we are in the middle of a debate, a national debate on our energy policy and how we, scientists and also young people, can really follow Dr. Hansen's steps and try to participate and contribute to this debate. Hopefully, leading Taiwan towards a more sustainable future. As our President Zhou, mentioned in his talk, our university actually, sustainability and geosciences are two very important building blocks of the future of our university. And students and our faculty members will try to really follow your steps and work on these problems. And hopefully, in the future, you will come back to NCU more often, sitting on the bench that's just dedicated to you this morning, talking to our students, talking to our faculty members. Thank you, Professor Hansen, and thank you, all the audience, for today's gathering. Finally, I'd like to announce this particular information. This is part of the 10 prize activities this week. And those of you who are not too familiar with the 10 prize, and those of you who would like to know more about Dr. Hansen, can go to the website of 10 prize, as well as the Facebook of the 10 prize. Okay, thank you.
Thank you, Dr. Liu. And thanks to all the distinguished guests for sharing such marvelous point of view. President Zhou, CEO of Tang Price Foundation, please come to the stage and having a group photo together. All of our distinguished guests, please come to the stage and having a group photo together.